Hello everyone, welcome to Java Expert. In today's video, we will discuss about Spring Cloud Gateway. What and why is Spring Cloud Gateway? If you see in the microservice architecture, we may have many services which will run with different port and host, right? So this maintaining this different host and port by the client who actually going to consume your microservices is going to be a big challenge for them. So that's where the place we need this gateway, to route clients requests to the corresponding downstream microservices based on some configuration and parameters. Okay, so API, basically the Spring Cloud Gateway is API gateway which is implemented by Spring Cloud team. It provides the simple and effective way of routing the API request to downstream microservices based on the different parameters and configurations. And one more thing is API gateway is one of the design pattern in microservices architecture, right? So if you see this, so API gateway design pattern will look like this. Is a very simple diagram where we can able to understand easily, right? So just consider here we have 4 different microservices and there is a client. So client will interact with your gateway only always. Okay, so client will not aware of what is the actual host and port where your actual microservices are running, right? So they will always interact with gateway, and the gateway will have some configuration, will have the intelligence to route your request to the appropriate microservices. So that's how we need to configure our gateway, right? Important parts of gateway. We have 3 important parts: route, predicate, and filter. So what is route? Route is the block which contains the URL to which incoming request to be forwarded. So basically in the route block only we are going to mention our actual microservice host and port, right? Then the predicate is the block which contains the condition criteria which would match to forward the incoming request to route URL. Basically, in based on what condition that particular request needs to be forwarded to that particular microservices. So here is the place we are going to define some conditions, right? Then filter is a block where you can modify your incoming request. For example, incoming request is coming with some parameter. If you want to modify that parameter, we can do that in the filter block, right? So these are the main part in the Spring Cloud API gateway. That's different types of predicates. So predicate is one of the important part, right? So in the previous slide we seen 3 different parts, right? So predicate is the one, right? So we have 11 different predicates, which means so when the client is giving a request to the gateway, so based on what parameter we have to route the particular request to downstream microservices. The request may have different parameters, different types of inputs it may have, right? May have a path URL will be there, header will be there, and the time when the request is getting initiated, that parameter will be there, cookie will be there, host informations will be there, method will be the HTTP method, post or so we may have a lot of information on the request, right? So based on what that request would be forwarded to downstream microservices, right? So we can we can write our predicates based on these 11 predicate factories, right? So in the practical session, we may going to do the path and header based routing in practical sessions. If you can able to understand path and header, then remaining things are very easy. You can do it with your own. So that much it is easy. It is right. Fine. So now let's move to practical session. We are going to explore path and header based routing. Right? Yeah. Let's start with practical sessions. Let's create our API gateway now. In last session itself, we have created account and fund transfer microservices using Spring Boot. If you are not aware how to create simple microservices using Spring Boot, you can go through our previous video. So you can able to easily understand how to create simple microservices, right? So now let's create API gateway. That's simple. Go to file, new Spring Starter project. It is same as how we have created account and fund transfer services. The only thing is the starter project is going to be different for gateway service, right? I'll put some banking gateway as name. Then remaining things are almost similar. Banking gateway. Right. Then click on next. Select point 6 point. Okay, we will change it. We are using 2.6.4. Okay, we will change it in the Pomodoro XML itself. Right. So here is the difference how we have created account and fund transfer. Right. We have used some starter project. So for a gateway, Spring Cloud API gateway, we have a starter project for that also. Just type gateway here. So you can find a Spring Cloud routing gateway. Select this, right? And as usual, we will select web project as well. Spring Web, right? I think that's enough, to configure very basic Spring Cloud API. Let's go. Right. So our project is getting ready. So project is ready now. So before starting anything, you will change this version to 2.6.4. If you're using 2.6.5, it throws some error in Pomodoro XML. So we will use this 2.6.4 version here. Now, our API gateway is ready. Now we have to configure for our account and fund transfer services. Based on what condition, based on what predicate, this incoming request needs to be routed to account or fund transfer services, right? In account and fund transfer services, we have used application.properties file to configure the things. Now here we are going to use application.yaml file. Both are going to serve the same purpose, but the content format will be something different. So you have to be aware of both the formats. So for that, we are going to use application.yaml file here. If you're using Spring Tool Suite, you have an option here. Just right click on the application.property file. You can able to find convert.properties to .yaml file. I'm now converting that to YAML file. Yes. Now open that file. Okay, now we're going to configure the things. As usual, we will give us some name for this. Spring application name. So format will be different, right? You can able to see that it will in property file it will be in a single line, but the structure of this YAML file will be a little different, right? I'll give the name here. Banking gateway, right? Next, so as we discussed in the theory part, we have three important part in the gateway, right? The route, predicate, and filter, right? So now we have to configure the route. So route for account and fund transfer, right? Now we'll do the route. So the route comes under Spring Cloud part. Cloud.gateway.routes, right? So now we are going to write the routes. Now we needed two different routes, right? One for account and another one for fund transfer. So now we will write the route for account. So first I have to provide ID for that. I'm giving ID as account route, right? Next, now given a unique ID for that. Now we have to configure what is the URI, right? Just put a URI. So what is the URI for the account service? So account service is running in my local, so I am putting localhost. If it is running in any service, you can mention the particular IP or host name of that. I'm running the account service with 3334, right? That's it. So this is the place where my account service is running, right? Now we have to do the predicate. So predicate is the condition. So based on what that incoming request from the client needs to be routed to this account service. So what is the condition? So we have seen 11 predicate in our theory session. So in practical, we are going to explore path and header, right? So in account section, for the account service, you use path, and the fund transfer, we will use header predicate. So account will use path. So path means, so in the URL, in the URI part, when you hit the request from the client, you will have a URL, right? The endpoint, right? So that if that particular path is containing this particular text, then that needs to be routed to this URL. So that's how this path will work, right? So now we want to know what is the path for account microservice. So go to account controller. So now this will be the path: banking account, then slash, it will be create account, banking account slash, then it will be get accounts. Because we have two different endpoints. So if your URL contains banking slash account, then that particular request needs to be routed to this account service. It may be create account or it may be get account. So this is our path. So here we have to provide this one. So which means if you are having banking slash account slash, then whatever it may be, it will go to your account service, which means localhost : 333. So it will go to that particular service, right? Now we have done the configuration for account service. Next, we will do it same thing for fund transfer also. So as I already said, we'll use path predicate for account and header predicate for fund transfer. So right now, we'll give ID for that fund transfer route. Okay. Next, we have to provide URI. What is a URI? So fund transfer is running in my local machine with 555 port, right? Next, we have to provide the predicates. So what's a predicate? As I already said, we will use header predicate for this. So we have to write header equal to, so what is the header we're going to use? So header will have a key pair value. What is a header? No key, what is the value? So we will put service as a header. So service, what service? It's going to be fund transfer. So if you have a header value, key as a service and value as a fund transfer, that particular request should routed to this fund transfer service, which means localhost : 555 port service, right? So now we have done the configuration for both account and fund transfer microservices in the gateway. Now our gateway is completely ready, right? Now we will start the services. So we will start our services one by one. Let me start account service first. So account service is started. Let me start fund transfer. So fund transfer also started. Now let me start banking service. So for banking service, sorry, not the banking service, the banking gateway, we are not mentioned in explicitly port for that. Normally we can do that, but we didn't do here. So if you're not doing the explicit port configuration for this gateway service, by default it will run with 8080 port, right? So we have to call our initiate a request for 8080 port. So let's start our API gateway service. So now API gateway service also up. So all our three services are up and running now. Let's initiate the request. So before that, let's know if you know how we are done for account and fund transfer services. We will be storing the data in the database. So we will check that also once. So here we have opened both the account and fund transfer databases, right? So initially it will be empty. If you want to understand how this works, you can refer our previous video, right? So now let's initiate the request here. Fine. Let's open the in the previous session we have tested this microservice with the actual port and host, right, where the microservice is actually running. So it will work like this. Okay, for example, our account microservice is running with the 333 port. So if we invoke this 333 and this endpoint, so the data will be stored. So we can go and check in DB, right? Okay, the same way if we go to our fund transfer also, we will be calling like this, right? It will be like 555 banking fund transfer and process. So if we click the request, it will be processed. Okay, so you can go to here. Okay, here also you can check it out. Data will be stored in the database. So it works. It works when we're calling the actual port where the microservice is running. Now we're going to test whether the gateway is working properly or not, right? So now just copy this entire URL which we have used already. Okay, so now instead of 333 we are going to use 8080. So 8080 is the port where our gateway is running. For gateway we are not explicitly mentioned the port, but by default it will run with 8080 if you are not mentioning it, right? So we're given the port here. Now endpoint you provide us, URI is provided as banking account and create account. Okay, now I'll copy this payload and provide it here, right? Now we'll see it out because we are not calling the exact microservice where it is actually running. We are calling the gateway now. We'll see whether the gateway is doing the proper routing or not, right? Yes, we call the gateway. It is being routed to the account microservice based on the configuration we did, and we got the response also. We'll see whether the database got impacted. Count. Yes, we do one more row also, right? Now the same way we will check it out for fund transfer microservice, because fund transfer microservice we did header based routing, right? So if you see here account service, it's getting routed based on the path. If your URL is having banking.account, it is being routed to our account service. But in case of fund transfer, we have configured header based routing, right? We'll do that. How we can. First I'll put a payload here. Transaction ID will be 2. So here we have to mention the header. So what is the header we have provided? We provided key as a service, and the value should be fund transfer. If a key is service and the value is a fund transfer, and our gateway should route this particular request to fund transfer microservice. Let's try it out. Yes, it works, right? We called the gateway, we provided the header value, and it's being routed as per our expectation, right? Let's see the database where we have data. Yes, it works, no? Yeah. So this is the way we have to configure our gateway. There are 11 different predicates we have. Now we have basic thing done with path and header predicates. The same way you can explore for other predicates as well, right? So as we have run for create account and process transaction, the same way you can use other endpoints also. We have other things, right? So get accounts, we can use it. Instead of create account, with the get account, it should be get method and send. You can see the list of accounts you have created, right? The same way here also we have in fund transfer, we have a get transaction endpoint. So instead of process transaction, we'll give get transaction and get method, get request. Yes, we got all the transaction. We created 2 transactions, we got 2 data, 2 JSON response. Yes, that's it guys. So this is how our Spring Cloud Gateway works. So there are many other things which you can explore yourself if you know the basic steps which you have done now. So the remaining predicates which you can use and explore yourself to explore many things. So I think that's it guys. So we're done with our practical session also. So I'll see you in the next session. Thank you. Hello everyone, welcome to Java Expert. In today's video, we will discuss about aggregated design pattern in microservices architecture. What is aggregated design pattern? Aggregated design pattern is the one of simplest design pattern in microservices architecture. Aggregated design pattern can be implemented as a aggregator service which will call more than one services based on the needs and collate the response. For example, client is requesting for a particular resource from the service, right? But to fulfill the client's request, we need a response from multiple microservices. And that is the case, and that is the place we should use this aggregated design pattern, right? So by seeing this simple diagram, you can be able to understand easily how this aggregate design pattern will be designed, right? Here, client is calling service 1, right? But to fulfill the client's requirement, the service 1 needs to call service 2 and service 3, and service 1 needs to aggregate the responses of service 2 and service 3, and that is the response for the client, right? So I think by seeing this diagram, you can be able to understand easily how this aggregate design pattern is going to work. Right, now we are getting to the coding part. We will now explore this aggregate design pattern in practical world. So guys, we already created account and fund transfer services, and we have tested it in our previous video. And in our previous video, we have created our Spring API gateway also, and we have tested with that, right? If you guys not aware of how to create simple microservices using Spring Boot, please go through our previous videos. You can be able to understand easily, right? So now today we are going to create aggregated design pattern in practical, right? So first we'll set our goal, we'll set our requirement clear first. Okay, here the requirement is we are going to create a report microservices, basically a report microservice. When a client is requesting for a report service, you'll give input as one particular account code, right? What the client is expecting is he needs the account information as well as the transactions happen through those accounts. So that's the expected response, right? So in this case, when you're calling this report service, the report service needs to call account service also to get the account information, as well as the report service would call fund transfer also, so get the transactions done through those account, right? Got it? Okay, so now if you see this requirement, we need response of one particular account, right? When you're giving one particular account, that your service needs to now retrieve the one particular account's details and the transaction done for that particular account, right? So if you know how we done the account and fund transfer, we don't have that endpoint to retrieve for a specific account code. We have endpoint for, if you take a account service, we have the endpoint for create account and get accounts, which means it will get all the accounts. It's not for one specific account, right? So now before creating the report service, you will create one more endpoint in the account and fund transfer services to get the particular accounts a result as a response, right? So we will create the endpoint first, fine. So for that to know, for it to get one account details from the account service, we'll create an endpoint. So before that, we'll go to the service first. So here in the interface part first, we will add that method first. So what are we expecting? We're expecting only one account as a response, or put new method as a get account, and it will return only one account. So there is no list here. We'll implement that method also, right? So what it's to return, so it should get account code as an input, right? So account code. So here also we have to provide that, right? So return, we have a repository dot. So here we have used save method and find all method in the JPR repository. Now we are going to use find by ID. So when we use find by ID, by default it will search based on the primary key we have used it, right? We are not mentioning which field it is, but we are using find by ID, by default it's going to be a primary key of that particular table, right? So here account code. So in accounts table, in the account service, the account code is the primary key, is the ID which I used it, right? So you can go and check that. If you go to this account, what you use as ID here is account code, right? So that will be used here. What is the error we are getting here? Okay, so it may be null sometimes. Suppose if you are not getting, if there is no data for the given account, it will throw the error, right? It will get some null pointer kind of things, right? So in here we have to use dot get. So when you're using this dot get, if you get the value, you will get it. If no, you will get some no such element exception kind of thing, will get it, right? Why you have to use, all right, account of string. Let's save. Okay. So now our service is ready. I'll go to controller. I'll add, just put copy paste here. We'll make it first. So here when we want to call this method, we need account code as a parameter, right? So get account, we will use path variable here, right? What it means, we are putting after slash, we have put this one curly brace and put here, it is like a query parameter. You can provide it here, not like a query parameter exactly, it is a path variable. Right. So right, so our account service is done. So if you call this endpoint and passing one particular account code, that particular account area alone we will get as an object, right? So account service is done. Now I'll do the same thing in fund transfer also. So in case of fund transfer, you just look at the model here. What is the ID we provided? It's a transaction ID, right? It's a primary key we have provided it, but we need a data, we need a output based on the account code from, because we have a criteria, filter criteria is account code only, right? So how we can do that here? Okay, so here this is the place we have to go to our repository. So here what we can do is we need to define our own method here, right? So just like public, what we need output, we are expecting list of fund transfer, right? We are expecting output as a list of fund transfer based on the account code as an input. Now we have to create our custom method, find by, and okay, find by what, based on account code from, right? I think account from. So we have to give that method name like this, account from. That's it. So we need going to pass an input for that, right? We are going to pass input as string of account code. How does work mean? See, okay, so find by, if by default we have put a find by ID, it will take primary key for the filter class, right? If you are providing find by account from, okay, you will go to fund transfer and what we are giving account from. So the value which you're passing in the argument, it will be filtered with this field, right? So we have to give this exact name, account from. So first letter alone we have to provide, you have to mention in the caps. So find by account from, that's it. Simple, right? Okay. Next, we'll go to our service. So we'll add that particular method. We need a list of fund transfer here also. So get transaction for account. So it will be account code. That's it, right? We will implement it here. Right. So we already created custom method in the repository dot. So you will get here find by confirm and account code is the parameter. Simple, right? Yeah. So this is done. Now I'll go to the controller. Same way, add one more endpoint here. So get transactions, get transaction for account. So here right. So now our fund transfer and account services are done. Oh, now we'll create our actual aggregator service, that is report service. We'll go new starter project. These things you already know. So we'll create report service. Right. Next, here we need only this Spring Web because we don't use any database here, right? Because this report service is not going to store anything here. It is going to call account and fund transfer service, and it's going to aggregate the response of both, and it's going to send back to the client, right? So we don't need any other dependency here. And finish. Okay, now the report project is building is happening. Okay. Yes, now report service is ready. In the resource, we'll mention the application name and port here. Service. We'll run with 777 support. That's it, right? That's enough as of now. Now we'll create model package. And we'll create service. And we'll create a controller. Right. So now we'll create a model classes. So what report service is going to do, it's going to call account and fund transfer. So we need these two models first. We can copy from our actual account and fund transfer model package. And just copy paste to report service and fund transfer also. Right, we'll get some error, we'll sort out. Here we have given some entity, JPA related annotations here, basically this entity related annotation which will map to database. This is not required here because report service is not going to deal with any of database activities, right? You have to remove these things. So we will remove those things from here because these things are not required actually. Right. So now we have account and fund transfer model. We need one more model to aggregate these two, right? So we'll create class, create class a transaction details, right? What it's going to have, it will have account and list of transactions, right? Basically list of fund transfer. Right, so this is what we are expecting as a response. No, if users giving one particular account code, we need that account details for the provided account and the list of transactions happen with those account, right? Done. Okay, now our model is done. Now we will write our service. We'll keep it as an interface instead of class. We will change it over there. So it's whenever you're using a service layer, so creating interface and implementing it is a good practice to make our components loosely coupled. We will be passing account code, right? Now we will implement that. We will implement that. So now here is the place where we have to invoke report service, account and fund transfer service, right? So we got a parameter as account. So this is a place you have to invoke account and fund transfer service, right? Let's do that. So for that, see, when you want to call other microservices, basically we will know normally we call it as inter-service communication, right? There we have many ways to do that, right? We can do it synchronized call, we can do asynchronous call, we can do message brokers, right? There are many ways. So we are going to use here REST template, right? Just see, it's the REST template is a client which we can use to invoke the services. Okay, so for that we need a REST template object first. So I'll do that. REST template builder. We have to auto wire this. Yeah, okay, now we have a REST template builder object here. So here REST template builder dot build dot, what I'm going to get as a response from the account service. We're going to get a account object. So we have to use the method get for object, right? So get for object, what is the endpoint and what is the expected response type? Response type will be account at class, right? This is the expected, this is the response type you're expecting, and the endpoint. So our account service is running in localhost with 333 port, and you have to give the actual no endpoint here, like banking slash account slash get account, and here we have to provide the account code which you are passing as an argument, right? Right. So what is the response you are getting? It account. So account response. Next we need transaction details, basically fund transfer details. Okay, so dot build dot for object, right? So here endpoint will be it's running with the 555 port, right? 555 banking fund transfer get transactions for account, then account code. Okay, this endpoint. And what is the response we're expecting? It's a list of fund transfer. So here I have to provide list class. So this is the object type we are expecting it. So the response will be list of fund transfer, right? So now it's done. Now we have a response of account and fund transfer. So we'll create the object for transaction data. So this is the object which we'll use to aggregate account and fund transfer responses, right? Now transaction details dot set account response dot set fund transfer response. Right now the aggregated object is ready. We will return that. Fine. Now we have called both account and fund transfer service for the given account code, and we have done the aggregation also. Now we'll write the controller. Right. We'll write endpoint here. That's some details. So here is the place. We'll mention a path variable. It will be account code. right? So I'll auto wire this service. Right. So I think we made one mistake here. That is in the implementation, right? Import. In implementation, we have to use that service annotation so that in this service class object will be created with a container that we can able to auto wire here. So we'll call the service method dot the transaction details of account code, right? So I think we have done that. Let's have a check here. Implementation, we call using the REST template here, and we are getting the response from both, and do the aggregation. Yeah, I've done. Now we will start our account and fund transfer service, and then we will now start report service, and we'll do the testing. Yes, account service is started. Next we'll go to fund transfer. We are not using the gateway here. It's also we can use, but this testing we are not using it. If you want to understand how this gateway works, you can go through our previous video. Now our account and fund transfer services are up and running. Now we will start our report service. Yes, now all three services are running. Now we'll go to Postman. So first we'll create few account and we'll do few transaction so that our report service will work, right? We need some data to try the report. So first I'll go to create account. Yeah, so this is a create account. Yes, so account code this 14x01 created. I'll create one more account with the savings account. Yes, two account were created. I'll create one more. Name is Java. Yes, we have created three accounts. Now we'll do some transaction using this account. Yes, in fund transfers, process transaction, right? We'll do that. So transaction number 1 and from account this one, and 2 account we can give anything. Yes, we are not used this 2 account for a filter. Give some 2 account. I'll do that. Yes, transaction 1 is created. So transaction 2, the same from account, right? Same account. Only some change the beneficiary name just to differentiate it, right? Now you've done 2 transactions with this particular from account. Now another one. On number 2 with some amount of 500 different IFS done, right? Yes, now we'll create 4 with the same from account. We'll change to account to this one and send, right? I'll perform 5. The third account will be this one, right? Okay, now we have performed 5 transactions. Okay, now we will check how this report service works. Okay, what is the endpoint you have provided for report service? We'll get it from there. Okay, so okay, we missed this one major thing. 1 minute. We'll stop the report service here. Okay, so this is REST controller, right? We missed this one. And request mapping. And slash report. Okay, so here remove that one. So banking slash report slash gets transaction details, and you have to give account code in the path variable. So here we have changed this one 777 banking and report get transaction of 1. Okay, before that we will start the service here. Yes, now it is up and running. Now we'll have a check. We're getting some error. Let's see. Okay, I think the path we are providing is seems wrong. Banking report the transaction details in account, right? Report the transaction details and this one, right? Ah, okay, this fund transfer is wrong. Okay, fund transfer. What is the endpoint for this one? Banking fund transfer get transaction for account. Get transaction for account, not transactions actually. I think this is the problem. Now try time. Okay, all we are running. Now give a try. Yes, we got a response. Just see the response how it is. See, we gave account as this one, right? 14 times 01, and we are getting account details here and the fund transfers. We perform 2 transactions using that account, so we got it. Now let's change it here to transaction account number 2. So we will get another 2 transaction, right? Transaction number 3 and 4. Account details also there. And 3, we perform 1 transaction, so we are getting this one, right? So I hope you understand how this aggregator design pattern works. So that's it guys for this video, and in the next session we will learn some another design pattern in the microservice architecture. So thanks for watching. Keep supporting. Bye. Hello everyone, welcome to Java Expert. In today's video we will discuss about circuit breaker design pattern in microservices architecture. What is circuit breaker design pattern? This circuit breaker design pattern used to build the fault tolerant applications. What is fault tolerant? So if you take microservice architecture, each service is going to run independently. It has its own task to perform, so it will run independently always, right? So whenever any one particular service is going down, it's went down, it does not mean that this entire application it is not responding, right? So we have to build application in such a way that even any one microservices went down, the microservices, the entire application should not went down, right? So the circuit breaker design pattern, it is similar to exception, but the circuit breaker design pattern provides us some additional functionalities which we can control the way how we are calling the dependent microservices, basically other microservices, right? Circuit breaker is a design pattern used to detect failures and encapsulates the logic of preventing a failure from constantly recurring unexpected behavior of services. So if we compare with the exception, what we will do not what we normally do is when we're calling a microservices, if it got failed, it'll go to the exception case and we'll do what we're supposed to do in the exception block. It will happen for all the calls, every calls. No, right? Even if you're calling 10 times, all the 10 times it got failed, the exception block will be executed, right? But in case of Microsoft, in case of circuit breaker design pattern, it provides to control the way we are calling it, right? So we know that if continuously service is getting failed, so there is no meaning of keep on calling that particular services. So we have to hold the request further to that and wait for some time to bring back those services, right? So those kind of things can be controlled through the parameters. We have a resilience force J, which is provided by the Spring Cloud IP things, so that we can use it to implement the circuit breaker design pattern. Right. Now the next point, it's especially useful when all part of our application are highly decoupled from each other. That's the nature of microservice architecture. And failure of one component does not mean the other parts will stop working, as I already explained. Building a fault-tolerant application where failure of some services should not bring entire application down. Right. We already stated that. By implementing circuit breaker design pattern, each component can independently upgraded, maintained without shutting down the entire application. Right? So this is one of the major advantages of implementing with circuit breaker design pattern. So we have 10 or 15 microservices. You can upgrade or you can maintain, you can download any particular microservices for maintenance purpose without bring down the entire application, right? By implementing circuit breaker design pattern, we can avoid unnecessary remote service calls when the particular service is unavailable. That's I already explained, right? So we keep on calling the particular microservices where it is down or it's not responding, then there is no meaning of calling again and again, right? So this is the points now you can note down about the micro circuit breaker design pattern. We'll move to next. There are different states of circuit breaker. When you're going to implement circuit breaker, you have a different state. Like first one is closed. So when everything is normal, so basically when we have a microservice A, we have microservice B, and we're calling A to B, it is everything fine. You're giving the request, you're getting the response. So that state is called closed. Basically, the circuit is closed. So the API call is continuous happening, right? Next state is open. The circuit breaker returns on error for calls without executing the function. So basically, when you're calling microservice A to B, microservice B is not responding. Maybe the reason may be various things. It may be down or this, maybe have some error in the service. So in such cases, so we will set some parameters in the circuit breaker when you're implementing it using resilience for J. So we'll set some parameter when the circuit should open. So that state called open state. And the one more thing is off open, right? So basically, when the circuit is open, then there is a time we will going to set in the parameter how long it should wait in the open state, and after that it will go for a half open, which means okay, the particular service is not responding. We open the circuit. So when we have to call back again, so we can't keep open for a long time, right? So half open state is a state where we will check the particular service whether it is responding or not after some time, right? So after some time of period, the circuit switches to half open state to test if the underlying problem still exists. Basically, whether the particular service is still not responding. So for that only. If a single call fail in this half open state, the breaker is once again tripped. If it is success, the circuit breaker reset back to the normal closed state. Basically, in half open state also, we can set the parameter how many requests it should test, right? So we can parameter 3 or 5 or 10 requests. It will know next 10 requests. It will give to the particular service in half open state if all are success, and it will close the cycle. If we understand these things, we'll move on to next. This is a simple diagram how the circuit breaker design pattern works. Okay, like client and gateway, we know that already things. If you are not know aware of what is gateway and all, you can refer our previous video. We implemented API gateway and service one. We have a service two. We have two service. Okay, here the this diagram depicts the open state because the circuit is open. When it is a normal thing, the circuit will be closed. Okay, now I think you would have understand the theoretical part. We are going to implement the same thing in the practical session also. Let's move on to practical. Let's implement the circuit breaker design pattern in practical, right? So we have many services. We already created it. If you are not aware how to create Spring Boot Node service application, I know you can refer our previous videos so you can able to understand easily. And for this circuit breaker implementation, we're going to use two services. One is fund transfer and rate. Okay, these two services we already created it. Right. What exactly is happening is the fund transfer service. We have a process transaction, endpoint, which will call the bank rates service and get the rate, and it will perform the transaction. Now we are going to implement the circuit breaker design pattern in the fund transfer. When bank rate service is not available, what's it do? Right. So that's what we're going to implement it now. For that, first we will add the dependencies. So this is the fund transfer service in format XML. So we have option. I am using Spring Tool Suite. So if you right click on that, you will find the Spring and add starter. So we can know add the starter of existing XML file itself. So we need couple of dependencies. One is resilience for J. So this is the one which actually support us to implement circuit breaker design pattern. And we need a Spring Boot actuator, so which will give the stats, the health related endpoints, so that we can see what is the state of the particular circuit breaker method, right? So I'm adding this. Apart from this, we need a one more. Because that is not coming in this one, so I'll copy it from outside. We need AOP. Basically, this is resilience for J. It is work based on the aspect oriented programming. So we need this dependency also. I just copied to form.xml, right? So now we have included all the dependencies. Let's move on to the codings. So first, I'll open the fund transfer controller. So this is the fund transfer method, process fund transfer, right? If you open this method, we have a, so we're opening this method. What we are doing is here. So from here, we are calling the rate service. This is the rate service endpoint, and we are getting the rate and we are performing the transaction here. So when the rate service is not available, what we are going to do? So that's what we are going to do. We are going to write circuit breaker for this rate service, right? So going back to controller. So here we have to mention circuit breaker annotation, and we have to mention two parameters. First one is name. So we are providing us rate service, and so here is the place where we have to mention fallback method, right? When the particular rate service is not available, which alternative method should execute, right? In current case, what we are doing is we are calling the rate service and we are getting the rate and we are processing it. In case that particular rate service is not available, we are going to perform the same transaction with some default rate without calling the service, right? So we have to mention the fallback method name here. So method name we can provide as process transaction with default rate. So this is the method we are providing it here. So we have to implement this method here itself, right? So public. So here the rule is the actual method and the fallback method, the signature should be same, right? Basically, the return type also should be fund transfer and this method, and you have to pass this parameter also fund transfer. And here is the thing, one more thing I want to mention. So when the particular service is not available, it is going to throw an exception, right? So for which exception this fallback method should be executed, right? We might have get to some different types of exceptions, right? So for which exception this particular fallback method should be executed. So here we are giving as exception. So you can note it if you can now write a multiple fallback method for each different types of exceptions here, right? So what we are going to do is here, no, we are writing one more method, uh, process transaction with some default rate. The method you will write here, all this method. So here we won't call this no service. We'll directly state.get rate and we are saving that, right? So here we have to write, we have to add it in interface also. Right. So we have implement this method called process transaction with the default rate, and this is the rate will be used here. Right. Now we'll come here. We'll call this. Yes. So that's it. So now and the programmatical way, basically in the programming things we have done that, right? So we have used the circuit breaker, annotation. We gave a name for that, and we wrote the fallback method, and we have implemented the same. Now we have to configure few things in the property file. Basically, we have a YAML file here. I'll do the configuration here. And in this YAML file, we have to. So these are the properties we have adding here to demonstrate our circuit breaker how it works. So now we are enabling the management endpoints here, and these all are for our circuit breaker related properties, right? So resilience for J circuit breaker instances, and this is RAID service, right? So this is the name which we have provided in the circuit breaker notation. So this name should be matched first, right? And this is our the controlling properties of the particular circuit breaker. Okay. So register health indicator. So we have to mention it. We have to make it as true, and failure rate threshold. So when particular services node is not responding, it's getting failure, we have to set threshold. I'm giving you one request that's got failed. So that's not mean that the service is still down. That may be many other reasons. So we have to set the threshold. Here we are setting the threshold in percentage, 50 percentage. If 50% of transactions got failed and the particular circuit should open. Okay, so that's we are setting in percentage. Now, minimum number of calls we mentioned is 5. So when I say the 50 percentage out of how many transactions, right? I'm making two transactions, one card failed. That's also 50% only. So we have to give some meaningful number here. Here I'm putting as 5 transactions. I'm giving 5 transactions here, minimum number of calls. Out of 5, if 3 got failed, it is more than 50 percentage. Now the circuit will get open, right? So we have to make minimum 5 transactions. Out of 5, it will check whether the failure is more than 50 percentage. Getting me right? And automatic transition from open to half open enabled. So when circuit is open state, when it should go to half open, it will happen automatically based on the wait duration. Next parameter I mentioned, no, wait duration in open state. When the circuit is open, it'll wait for 5 seconds and it will go to half open automatically after 5 seconds. So that's the two parameters. And permitted number of calls in half open state. So when circuit is going for half open state, it will try for next 3 transactions. Next, it will give the next three a request to check whether the particular service is responding or not. So we stated we mentioned as 3 now. So it will give three requests. And sliding window size is 10. So which means what is sliding window size? 10 means uh, when you're giving any request, right? The last 10 request outcome will be stored, right? So last 10 request no processed or success or failure, so those stats informations will be captured. So that size only we are defining in this sliding window size. So you're given 10. Sliding window type count based, right? So this entire thing can be configured based on the count based and time based. Also we have one more parameter. So here in five transaction, in five we are checking the 50 percentage. So instead of that we have one more parameter called time based. In 1 hour how many transaction, how much, no, in 1 hour whether it's a 50% or failed or 20% got failed. So this parameter can be determined based on the time as well as count. We are going to demonstrate using the count based, right? So I hope you understand the circuit breaker related properties. We have many more properties here, so you can check it out here. We have, I think, I've taken for you. Let me show. So here, if you go this, we have many other parameters. So you can just when you go when you try for the circuit breaker resilience for J, you try with this all these parameters. We used minimal parameters just to demonstrate you, right? Now we'll start the service. So I'm starting fund transfer first. Right. I think fund transfer is started. I'm starting rate service now. So first we'll start both. I'll go for some success case first. Right now, fund transfer and rate services are up and running. I'll go to Postman. I'll give the request. Right. So first we'll check the health because we have enabled health endpoints. So our fund transfer is running in 555 port and actuator and health. Okay, so if you trigger this, we can see our rate service status is closed. The circuit breaker status is closed. We don't make any call, so all the parameters are zero here, right? Now I'll go to fund transfer endpoint. So fund transfer endpoint. I'm giving one request now. Yes, we got a response. It is success now. We got a response. I'll go to get no actuator endpoint. We'll see here. Buffered call is we made one call. Still it is closed and there is no failures, right? Fine. Now we'll bring down the rate service so that we can check how the circuit breaker works. We are bringing down the rate service. Now I'll go to that. Now I'm changing the transaction number alone. Previously we gave 1000 and multiple by rate. I think we are given some 3 point something rate. Some rate we are given based on it came as 10,000 some 300 value. I'm giving one more now. See now this time also give the same amount, but now the amount is coming as 70,000 because we some process for some default rates. We hard code some rate, right? So it is going to the fallback method and it got processed. Now we'll go and check the actuator, check the circuit breaker status. We made two calls, one got failed. So what is the threshold we gave? 50 percentage of the for a minimum number of transactions would be 5. We made two calls. Now we made another. Three success, four, five. Now we made five transactions, right? Out of five, I think only one is success. Remaining four are no executed in the fallback method. Now I'll go and check here. See, here we are seeing half open. The reason is waiting state in the open state we gave us 5 seconds, right? So this 5 seconds is over before we execute in this health endpoint. So it is showing us half open immediately, right? So what we can do is we will change the status, right? So I'm going here, stopping this. We'll extend this time. We gave us 5 seconds, right? We gave us 20 seconds. I'll start it. So we have started it now. We go back again. Now, since we are restarted, everything will be resetted. Now, initial will be closed. Now we will give 1, 2, 3, 4. We set minimum of 5 transactions. We did for 4. If you come and see, still it will be closed only because we set a minimum itself for 5 transactions. Now we'll go for another one. So now we have done 5. All 4. Now 5 failed, which is more than 50%. If you see, it is open state. So wait for 20 seconds. Automatically it will be half open. Right? We'll wait for some time, and we can check the same health endpoint. It will be half open. So that's what you have mentioned. It is. It's not a. Yeah, it is 20 seconds is over. Now, if you see, automatically circuit is came to half open state from open state. Right now, it will what will do is, in half open state it will give 3 requests to check whether the particular particular API is bring back. So that's what we mentioned here. So we give 3 more transactions here. Still, note that rate service is down only. Now we give one more transaction. 1. We set as 3 in the half open state. We give 2. Come and see. It will be still half open because we set 3 transactions. We give only 2. Now giving one more. Now we gave 3. All 3 got failed. Come and see that it will be open set again. It will go to open again. Right. Now we will start the rate service. We'll check how the circuit is getting closed. Yes, now rate service is up. Now I'll come check the status. It is half open. So here we have to provide another 3 requests. 1, 2. See, we have started, that's why we are getting the actual rate from the rate service. And third, yes, all 3 success. Now come and see here. It is now in closed state. Right. So I hope you understand how this circuit breaker design pattern works and the way we are implementing using resilience for JAP. So that's all about this video, guys. I hope you understand, and if you have any feedback, you put your thoughts and comments and like and share this video with your friends, and subscribe this channel also. Thank you. We'll see you again in some time. Thanks all. Hello everyone. Welcome to Java Expert. In today's video, we will discuss about chain of responsibility design pattern in microservices architecture. What is chain of responsibility pattern? Chain of responsibility pattern provides a single output which internally combines the chain of multiple service outputs. Basically, when you are giving any request to any service, that particular service may internally call multiple services to fulfill the client's request. Right? Chain of responsibility pattern can be implemented via synchronously or asynchronously. Always recommend not to chain more number of services, which may lead to keep client wait for more time. Right? No, since we are chaining the services one by one, if that number of chaining is getting increased and the client needs to wait for more number of time, right? That is obvious, right? because internally we are making multiple calls. So obviously the client need to wait for long time. So there is a recommendation not to change more number of services. This is a simple diagram. So by seeing this, you can easily able to understand how this chain of responsibilities and pattern works. Right. So in this diagram, client, giving the request to service one, and service one invoke the service two, and service two invokes the service three. There is no limit that we have to use only the three services in the chain. No, not like that. It is not in that way. If the requirement needs, then you can increase the number of chaining, but anyway you have to consider in the response time also. If we keep on increasing the number of chainings, the response time will increase. The client needs to wait for more number of times, right? So we're going to perform one simple example to show how this chain of responsibilities and pattern works. So this is the example we are going to do it in practical way. The client to transaction service, and transaction service internally going to call rate service. We are going to chain only the two services, transaction service and it called the rate service. That's it. The simple example we are going to show it in the practical way. Yeah, let's get into the practical. So as you know that we already created many services in our previous videos. We have created fund transfer, account, banking gateway services, and now report services we have created. And now we have already done the practical session for a few design patterns as well, right? So in on top of that only we are going to show how this chain of responsibility design pattern works, right? So I have created bank rate as a service. Already have created this one because see, this is nothing new in this bank's rate service. If you know how we have created account or fund transfer service, and this is in the similar way. So that's the reason I don't want to waste your time. So we already created it. I just show you what are the things we have done that in a simple way, right? So we have a controller here, and we have done the endpoint as a cross rate, and we have a model. So we have a from currency to currency and cross rate. Very simple model we have here. And we have a service. We have a service interface, and it got implemented. The implementation is just simple implementation. I gave you nothing fancy, or is not a production created rate module. Just to show how this works, I just put up the from and to currencies are same, and the rate will be one. If the difference one, I just fix the rate. Okay, there is no currency code based calculation. I just fix the rate, right? So this is the bank's rate service. So this bank's rate service will be invoked by fund transfer service, right? So fund transfer service we have to update here because I have not done that. So let's do that. So we have fund transfer service implementation we have here already. So here we will implement that one. So cross rate we have already created here. So what we have to do is in the service fund transfer service, whenever you are going to create the transaction, you are going to process the transaction. If you are not aware of what we did in the fund transfer service, please go through our previous videos. You can able to understand easily what you have done earlier in the fund transfer account services, so that you can able to relate what you are trying here, right? So you can able to relate it easily, right? So we are going to call this bank's rate service from here. So what we have to do is first we have to create a bank rates object here. So that's we have model as a cross rate. New cross rate of. So what are things we have? We have a currency. I just put this fixed as INR only. Right. So we are going to get the rates from rates model. So for that we need to give a input object as a cross rate, right? So we'll inject REST template builder. Right. Now let's call our service. Build dot You can use this method. Yeah. So first things will be URL. So we are created the service closed. This is the port we are used to expose our bank rates module, right? Banking rates cross rate was the endpoint. Okay. So next is what is the method? HTTP method dot suppose method, and what is the response? No, basically the request entity we have to pass, right? So request entity of the request the request is cross rate, so I'll pass that one. And the response type also cross rate dot class, right? Getting some error, we'll see what it is. Method HTTP entity HTTP entity of request entity and response type. So basically it's not a request entity, it's a HTTP entity, right? So this will return the response entity. So response entity of cross rate equal to response entity, right? So what we can do is, so once we get the rate from the bank's rate service, we just multiply with our amount which you are receiving in the process transaction method, right? So first we will take the cross rate, use the same object, we will override that object here. So object will be in the get body, right? So now we will override the amount. Right. So in the fund transfer dot set amount, fund transfer dot get amount multiply by cross rate dot get cross rate, right? We nothing doing fancy here, we just get the rate and we simply multiplying that rate with the amount which you are receiving it, and you are saving that object in the database. That's it, right? So let's start the service, both services, and we will now test this one. First we'll go and check the bank's rate service. We'll show that application or property. So this application name we have, and 987 is a port which our bank rate service is running. Let me start this one. Yeah, it is started. Now let's start fund transfer service also. Yes, both services are started now. Now let's test our service. Open the Postman. Right. So first let's test our bank rates service separately. No, right. I'm just giving the from currency and two currencies same INR and INR. Let's see what is the response we are getting it. We are getting cross rate as 1 because we are giving the same currency. That is what the service implementation we did. If the same currencies are given, then the rates will be 1. you are giving any different currencies, for example INR to USD, and we'll get some 10 point something because the rate we have hard coded over there in the code, right? Just the example is not in a fraction grade rate module, just show you how it works, right? Now we invoke our actual process transaction service basically, right? So this is our JSON. We are giving transaction ID from account to account. These things you know already. We have seen our fund transfer module, right? So I'm giving amount as 1000, right? Because there I have a hard coded currency from currency to currency as INR and INR only. So I'm giving the request now. Now we got the response. Amount is coming as same because there we hard coded currencies, right? In the code, what it is, we hard coded the same currency, so it will return the rate as 1. So 1000 multiplied by 1, it will be 1000 only. Now what we can do is we will change the rate here and we will try now. We stop this. Now I'm changing INR to USD, right? Now we'll start the service. Now what we are expecting is we are expecting the rate should be 10 point something, which we are hard coded in the rates module, and that should be multiplied with the amount which you are passing in the JSON request, right? Let's try now. Now I'm giving the same request, nothing changed. I'm giving the same request. Let's see what is the response we are getting it. Yes. Now what is the amount you are passing is 1000, and since we are giving from and to currencies are different one, so we are getting rate as some 10.34 something rate we are getting. The rate we hard coded in the rates module, and that is multiplied with the amount which are passing in the request, right? So what we are trying to learn here is this is how this chain of responsibility design pattern works. We are giving the request to transaction module. Transaction module internally calls the rate module, and it will complete the request of the client. You got it, right? So that's how this chain of responsibility design pattern works. We have done only the two chainings, right? Because just to show how this works. So in the real time, we may have a multiple service may be chained, right? So we are not I show you the very simple example because that is nothing fancy or nothing new we're going to learn with this one. It's a very simple thing, so just want to show it in the practical way how this works. So that's what I have tried to show that, and I have done that, right? So I think we have understand how this chain of responsibilities and button works, and in the next session we will see the some other design pattern, the practical exams. Thank you guys. Thanks. Hello everyone, welcome to Java Expert. In today's video, we will discuss about asynchronous messaging design pattern in microservices architecture. What is asynchronous messaging design pattern? Normally, when you are calling a service, for example, we have a microservices A and microservices B. If we call a service A to B, so A service will invoke the request to B service and will wait for the response, right? Till we are getting the response from the B service, A service will hold the particular thread for the response. So that is called synchronous messaging. In case of asynchronous message, the sender service will send the message and it will forget it. Basically, it won't wait for the response from the receiver service. So the receiver service will receive the message by its own time and that will process it. Right? So that is called asynchronous messaging design pattern. Asynchronous messaging design pattern enable us to loose couple the services, basically decouple the services. Asynchronous messaging design pattern help us to improve the performance, scalability, and reliability. So when we need this asynchronous messaging design pattern, so based on which we have to design a microservices with asynchronous messaging design pattern, right? So we may have a multiple, more number of services. We may need to interact. Basically, inter-service communication. It is must when you are designing a microservice architecture, right? So when you want to improve the performance and you want to completely you want to decouple the services and you want to scale independently, in that cases we have to use the asynchronous messaging design pattern, so that even the particular service is not available, the other service will not get any impact. It will run as it is being designed, right? Because when we are going to implement microservices application, no, based on microservices architecture, if we are going to use asynchronous messaging design pattern, we have to use message brokers, right? So even the targeted service is not available, the message will be stored in the message brokers. Once the targeted service is up and running, it will receive the message from the message broker and it will process it. So that's the beauty of asynchronous messaging design pattern. So one of the very important design pattern in the microservices architecture. If you want to design any application using microservices architecture, you have to consider this design pattern very carefully, and wherever it is required, you have to implement it properly. So this is a simple diagram how the asynchronous messaging design pattern looks like. So very simple diagram. You see that client will initiate the request to service one. Now the service one wants to send a request to service two. So if it is a synchronous call, it will initiate the request. It will be the direct some kind of HTTP request sent to service 2 and it will wait for the response. In case of asynchronous, we will have a message broker between service 1 and service 2. So service 1 will place the message into message broker and that's it. Service 1 will forget the request. And service 2 will receive the message from the message broker and it will process it. Right? So this is example where we are going to implement it. So we will be developing a order service and we are going to develop a dispatch service. And in between, we are going to place the Kafka messaging service, basically Kafka topic. So this is a practical example. We are going to do that. So here we are going to use Kafka messaging service for the message broker. So steps to implement asynchronous messaging design pattern. So these are the things we have to follow in order to implement the asynchronous messaging design pattern. The first step is understand asynchronous messaging design pattern, which we did now. So whatever very basic thing I have been explained to you, what is asynchronous messaging design pattern means. I hope you understand that. The next step is we are going to understand very basic concepts of Kafka messaging service. We are going to understand what is messaging service and what is Kafka messaging service, and we are going to install Kafka messaging service in our system. So that's going to be the next video for us. And the last video for this asynchronous messaging design pattern will be we're going to implement asynchronous messaging design pattern in microservices architecture by integrating Kafka with Spring Boot. So, and the last video we are going to demonstrate how asynchronous messaging design pattern will works, and we are going to use Spring Boot to implement, and we are going to integrate with Kafka for the message brokers. Alright, so that's it for this video, guys. So I hope you understand the theory part of asynchronous messaging design pattern. So I'll see you in the next video. We will learn about Kafka messaging services and we'll install and we'll test that. Thank you guys. I'll see you soon. Hello everyone. Welcome to Java Expert. In today's video, we will discuss about Apache Kafka integration with Spring Boot. First, quickly we will discuss about what is Apache Kafka. Apache Kafka is a distributed event store and stream processing platform. It's nothing but a messaging system. So whenever we want to integrate any services in a synchronous way, we need a messaging system in between these services. So that's where the place where we can use Apache Kafka as a messaging service. Apache Kafka combines three main capabilities. The first one is to publish and subscribe to. Second one is to store. Third one is to process. To explain in detail, so Apache Kafka is having ability to publish the message, is writing the message to the messaging system, and subscribe to, which means reading the messaging from the messaging system. Let's have these capabilities. And second one is to store. So whenever we are publishing any messaging into any messaging system, that message has to be stored somewhere. So it's having that capability. And third one is to process. So whenever you are publishing a messaging into any messaging system for Apache Kafka, that will be processed by any consumer which is subscribed to the particular topic. We'll see what is topic it is later, and it can be processed events as they occur. It can be at later end point also. So next we will discuss about topics in Apache Kafka. So topic is the one of the important or main component in the Apache Kafka. So whenever you are publishing any message or a event, that's are stored in the topic. So events are organized and durably stored in topics. So topics in Kafka are always multi-producer and multi-subscriber, which means in a particular topic, more than one producer can publish a message. The same way, from the topic, more than one consumer can receive or no subscribe the message from the topic. So that's where they are mentioning as multi-producer and multi-subscribe. So what is the best use case for Apache Kafka? Where we can use this? So it can be used in many places or many use cases are there. So one of the main use cases will be like in the microservices architecture, whenever you want to integrate two services in asynchronous way, then we can go for Apache Kafka as a messaging broker or messaging service. Right. So I hope you understand very basic things about Kafka. So this is a very basic diagram how Apache Kafka works internally. Right. Okay. So here we have a producer, then we have a Apache Kafka cluster. So cluster means the cluster will have more than one broker. Broker means it's a Apache Kafka instance, right? So cluster will have more than one Apache Kafka instance. We call it as a broker. So in this diagram, we have two brokers, broker 1 and broker 2, and each broker will have more than one topic. So if you take a broker 1, we have a topic click and topic upload. And the same way, broker 2 also is having topic click and topic upload. So same topics are there. So this is where the place we have to think about distributed system. So why are you having the same topic is in multiple brokers? To maintain the fault tolerance. Even the broker 1 is not responding or it's went down, broker 2 will serve for us. Okay, so the same message will be replicated into multiple topics. So that's based on our requirement. We can maintain multiple brokers of the same topics. So our fault tolerance can be maintained. And each topic will have a partition. Okay, so what does partition mean? Why it is required? So there may be a requirement where we have to process the messages from the topic in parallel way, right? So as we already discussed in the previous slide, multiple publisher can publish a message into a topic. At the same way, multiple consumer can receive the message from that topic, right? So as we are creating the partition, we can enabling the parallel processing. So if we take a topic click, we are going to have a three partition 1, partition 2, partition 3. So producer will publish the message into different partition, and the same way consumer also multiple consumer will receive the message from the each partition and will process it. And the order of the message, in which order the producer is publishing the message into the topic in a particular partition, the order will be maintained. Which means in which order the producer is publishing the messaging into the topic, the same order consumer also will receive the message. Right. So I hope understand how it is basically works. And this entire system, like this Apache Kafka cluster, this entire things we call it as Apache Kafka ecosystem. This entire ecosystems will be maintained by Zookeeper component. There is a component in Apache Kafka itself is called Zookeeper. So that will be maintaining or managing this entire Apache Kafka cluster. Right. So this is going to be a practical example. So we are going to have a client. We will use Postman for that, and we are going to create two services. One is going to be ordering service, and another one is going to be dispatching service. And we are going to place Apache Kafka in between these two services, and we are going to test how this asynchronous messaging design pattern works and how Apache Kafka works. Right. So this we will see it in the practical session, and before that we have to install our Kafka in our system, right? So next we will install our Kafka service, and we will test it, and then we will integrate with Spring Boot. So Apache Kafka, the latest version can be downloaded from this one, Apache Kafka org downloads. So you can download Kafka 2.13 version. So this one you can download it. As I already download and have installed it, I'll show you. Once you have done the download, just extract it in your local. Once extraction is done, there are a few places we have to update in the configurations in the Apache Kafka libraries, and then we are good to start with it. Okay. So once you've done the download and you extracted the files, you can see like this, like config, libraries, license logs, everything will be there. Go to config and go to zookeeper, edit this file. So here you have to update this to your local path. So I have stored this Apache Kafka thing here, e software Kafka, and this is the path I have stored. So same way, you have to provide your local path. So once this is done, then we are good to start. So first, go to this path, Apache Kafka root directory on the command prompt. So first we will start the zookeeper service. So once the zookeeper is started, so it will run with a 2181 port, the default port. So once that is done, then we will start the our actual Apache of Kafka server. Go to then the same folder, execute it. Okay, once Apache Kafka server is started, and next we will no we will create the topic here. We're going to create the topic. So Apache server will run with 9082. Apache Kafka will server run with 9092 port. Sorry, 9092 port. Now we will create a topic. Okay, I'll create topic called my first topic. Okay, okay. Topic is created. You can see here. Now we will test it. We will publish the message and we will consume the message how it is works. Okay. So these all are the I am running with Windows, so I'm using the Bash script. If you're using Linux, there is a shell script also, so that you have to use it. So these are the commands for this we already know noted down here. I will provide this in the video description. You can find over there. So first we will start our consumer. So now we have started our consumer. So consumer is ready. Now we'll start our producer. So once you started the producer, you can okay. Once you started the producer, you can provide the messages, right? So I'm going to test. So you can see it. No, I am publishing the message from the producer. The consumer is getting the message here, right? My first message. Yes. Okay. So we have installed the Apache Kafka, and we have tested it is working fine, right? So this installation is very easy. Now we have created one topic. There is no we are using the default of one partition. So we are publishing the message in the producer using the producer.batch file, and we are running the consumer.batch file. So both the places you have to mention what is Apache Kafka server system and port. We are mentioning the topic in the producer. You are mentioning in which topic you are publishing the message, and in the consumer also you are mentioning from the which topic we have to consume the message, right? So I think this you can easily understand how to install the Apache Kafka, how to test with using the command prompt, right? So this is fine. So we'll shut down consumer, down producer, right? And next, that this thing, Apache server, so Apache Kafka server and Zookeeper, let it be running because we are going to integrate this Apache Kafka with Spring Boot, right? So we're going to create the order service and dispatches of it, and we're going to test over there. Okay, let's start with that. Yeah, so let's create our order service first. So the same way, we'll name it as ordering service. So you can just fill this details as per your requirement. So dependency you have to add Spring Web and Spring Apache Kafka. So these two dependencies you have to add next and finish. Okay. So here our ordering service is going to be our publisher, and dispatcher service are going to create, that will be the our consumer. Okay. So ordering service. So inputs are loading. Wait for some time. So ordering service is ready now. So now we will write our publisher related code here. So here we'll write basic on endpoint here. Public string place order service, right? Return order placed. So basically what we are going to do is, when you're calling this endpoint, this message will be published into Apache Kafka topic, right? So there will be another service you're going to write called dispatch service, that will be the consumer for us, that will consume the message from the topic, and there we will print it, print the message. Okay. So post mapping. Okay. So here we need Kafka template to publish the message. Okay, so it's going to be key pair, we have to provide it here. So it will be a string and the value will be in object, right? Okay, right. So now we need entity, right? So we'll create an entity first. Create order entity, right? Order ID and order description amount. Amount will not be string, but just to demonstrate you, I'm keeping as a string. So present setters are ready. So order service is ready. So here it will be order, right? So here we will publish the message. Okay. So before that, we have to mention our what is topic name. Okay, what is the topic name we have provided is my first topic, right? Look at the same thing, my first topic. So here we have to place the message. A template dot send. Here we have to provide our topic name and our object, which needs to be published. Okay, right. So now we have to configure our Apache Kafka server related details. Okay, so we'll create a config package. Kafka. Okay, started with that configuration. Right. So to create a producer factory bean producer factory. Okay, so we'll create a map. Create the map. We'll add few properties inside the map. So we have to provide the bootstrap or no server config. So it's going to be localhost 9092, right? And then we have to provide those serializer details. The serializer class config. So that will be string serializer. Serializer dot class. Serializer config dot value serializer config class. This is going to be JSON serializer because we are using the REST endpoint and we are going to use JSON as a input format. So it's going to be in JSON format. So it's going to be JSON serializer. JSON. Okay. Serializer dot class. So now that's it for producer factory called So we have to pass config. That's it. So now our no producer factory is ready. Wait with the green. Now we'll create a Kafka template. Kafka template. So here factory. Right. So now config is ready. So that's it. Our producer is ready now. So I'll just server dot port. We'll run this one with 8081. So producer will be an 8081 port. So now we will test this producer how this works. Okay. So start our application. So now producer is ready. So now we'll create our consumer. So we'll create our dispatch service, dispatching service. We'll fill the details for dispatching service. Dependency is going to be same Spring Web and Spring Apache Kafka. Finish. Let's create dispatching service. It is created. So we'll write the code for our consumer. First create our entity. So our entity is going to be same as order class. So I'm copying from the ordering service here. So entity is ready. Now I'll wait for configurations. So Kafka configuration. So write our configuration here. So here we have to create a pin for consumer factory. Click the factory going to be click, right. So it's going to be similar like producer only. So we have to create a map. New hash map. Right. So config dot. So we have to add few properties here. consume dot host of server config. So it is going to be same localhost 9092 and then pick dot put pick dot. Now in producer we have added no serializer config. Here we have to add deserialized config. Okay. So key deserializer configs it's going to be string deserializer dot class. And for a value serializer, no, see, in the producer, we are going to publish our order, no, JSON. Basically, Java object we are going to publish over there, right, in a JSON format. So when you are consuming in the consumer end, when you're going to deserialize it, so we have to add this property, JSON deserializer. So we're going to no, deserialize the order object, right? Going to create object for this. Provide order dot, right? Okay. And you have to add a few, you have to set few properties here, or like that user the type is as true dot add trusted package and to mention dot floating all the packages, right? And then this has to be added in the config dot put config dot value serializer config is going to be value serializer object. Okay. And we have to mention the dot dot we have to mention group ID. See, because we may have a multiple consumer for a topic, so those consumer can be grouped using these group IDs, right? Okay. So, for example, order is an event which is triggered from the order service that should be received by this consumer. From the same topic we may have other no message or other event also, right? So that needs to be consumed by the different consumer. So that can be grouped using the this group ID config. Okay. So we'll provide some name. So this is no order, right? So we'll provide name as a order group. That's it. Now return new world of the consumer factory config the new thing. Then this value serializer we have object already, so that we have to pass it here, right? Okay, now consumer factory study. So now create our call listener bean concurrent Kafka, listener, container factory. Yes. And Kafka, listener, container factory. It factory dot consumer factory. All this method. Then and factory. So Kafka configuration for consumer is ready now. Write our listener class now. So now we will write our listener class here. Big void order message. Message which is published from the order service will be received here. Put name as order message. Will like payload. Okay. So here we have to annotate with the Kafka listener. We have to provide few things. ID. So what we are given? We are given as order underscore request. But mention the group ID and topics. I first pick contain factory container factory given. This one Kafka listener container factory. This you have to provide here. So once message received here, you have to process it. So just going to print it over there. Nothing you're going to do. Okay. Order dot toasting. That's it. Okay. So what you can do is override dot toast. Okay. So our consumer also ready now. Dot 8082. Is in 8081 and consumer is in 8082 port. Start this server. So consumer also started, so you can console here like so is assigned for my topic and zero is zero partition zero. This group details are displaying here, right? So consumer is ready now. Upload is also we already started it. So Let's trigger the message. Okay. Order service ready. Dispatch service also is ready. Go to postman. So this is our thing, right? 081 order. So getting a response is the order placed. Go to consumer. You can see the console here. We got the message in the consumer, right? So order service is publishing the message into topic. My no, my first topic. So order service publish the message into the topic, and our consumer, that is the dispatching service, is receiving the message. So it is displayed here. So we have now printed the message. So that is, we'll put one more message. Order ID ORD 001 computer. Amount is 30,000. The request. So we gave two requests. So both no message got received at the consumer end. Okay. So that's it, guys. I hope you understand how to create, Kafka consumer and Kafka producer in Spring Boot, and we have demonstrated how it is integrated in a synchronous way. Right? Thanks for watching, guys. I'll see you in some another video. Thank you.